Right, okay. So, which pen were we writing with? Blue. Morning. Just tell him Ms. Bartosh will be checking as to see whether the matrics will finish on time. If not, we will do our sale on Wednesday. If they are finished on time, she will let him know when. Okay. Right. We said that acids always contain what? A hydrogen. What do they do with that hydrogen? They donate it in the form of an H+. So for example, if we had HCl plus, let's take water as an example, what will happen? That HCl will donate what? An H+. Don't just say a hydrogen. It's not the same. It's a hydrogen without its electron, which is a proton. And that will change the H2O into what? H3O positive. And what does that leave this as? Cl1 minus. Because the electron that normally goes with the H has been left behind. So it is Cl minus. Okay, that's your normal protolytic reaction. What we call a protolytic reaction. We spoke about that on Friday. What I would like to look at now are bases. So, turn back in your notes. How did we label acids? Was it 1? Was it A? Was it, I think it was A, was it? Okay, so if A was acid, then B is bases. Right, could anyone give me some examples? NaOH. Sodium hydroxide. Right. KOH. Potassium hydroxide. Calcium hydroxide. CaOH in brackets 2. Give me another one with 2 of them. With 2 OHs. Magnesium hydroxide. Sodium carbonate? No. It fizzes, that is sodium carbonate, yeah. Lithium hydroxide, that's a 1. I'm looking for one with 3 now. 3 OHs. Aluminium hydroxide. AlOH3. Okay, now, could anyone tell me which one of these bases is the strongest? This one? That one? Generally the ones with only the one are your stronger bases. So these are your stronger bases, these are your weaker bases. These are the strong ones. And these are your weak ones. But one thing you will have noticed that all bases contain, they contain at least one OH, sometimes up to 3 OHs. There are some exceptions. NH3, what is that called? Ammonia, is that a base? It is, because what happens when you add water to ammonia, what does it change to? NH4OH. Okay, and that is ammonium hydroxide. So ammonia is a base when dissolved in water. Okay, water gives it one H plus, gives you NH4 positive, leaves behind the OH minus, the NH4 positive and the OH minus get together to give you NH4OH, ammonium hydroxide. So you can just make a note with that, that all bases contain one or more OHs. Okay, you all got that down. Now, what I've given you here is really what we would call a really crude definition of an acid and a really crude definition of a base. What did we say a definition of an acid is? Any compound that contains hydrogens. And a base? Any compounds that contain OH. Now, that would maybe suffice if you were in grade 8 or 9, but 10, 11, and 12, we need to get a little bit more complex. So, basic definitions. Can you see this? Okay. I'll just carry on for the next 2 minutes until we can finish this, and I'll do the next lesson with ordinary cokies and won't record it. Okay, basic definitions. Acids contain one or more H's. Bases contain one or more OHs. Example, HCl and NaOH. Happy with that? And this is not for tests or exams. The Arrhenius theory of acids and bases. So according to a scientist called Arrhenius, an acid is something that forms either an H plus or an H3O molecule in water. So example, we know that HCl, we know by now it is an acid. If I put it in water, it breaks up into what? H plus, aqueous, plus Cl minus aqueous. HCl, you put it in water, it's going to split down there, H plus, Cl minus, H plus, Cl minus. What happens to that H plus plus other waters? It's going to form H3O positive aqueuses. Okay. So, according to Arrhenius, acids form H plus or H3O positive when they're in water. There's how an acid, HCl, it splits down the middle, the positive part, H plus. The negative part, Cl minus. There it's formed an H plus in water. As a matter of interest, that H plus can link up with other waters to form H3O positive. Can anyone tell me what AQ means? What does that mean? The waters are packed around them. Remember we did that with bonding? Who doesn't remember? Hands up. Let's have a quick look. If you have a positive ion, okay, how will the waters bond around that? Which part of the waters will be pointing towards the positive ion? Which part of a water molecule is negative? The oxygen bit. Okay, if you don't know those basics, you're going to come short. Okay, O, H is positive, H is positive, the O is negative. Okay, due to not equal sharing of bonds. What do we call bonds where the electrons are not shared equally? Polar bonds, okay. If that was a negative ion, how would the waters be packed around that? The hydrogen portion, the positive portion, pointing towards the ion. Hydrogen, hydrogen, oxygen, like that. That's what aqueous means. Waters packed around that ion. Okay, we're all happy with that? Okay. So that's Arrhenius' theory. The last theory that I want to give you is the Lowry-Bronsted theory. And the O in Bronsted has got a line through it because it is Scandinavian. How are they doing?
Okay, just some tricks have just finished at 10 o'clock. All the extra time is learning extra time.
Okay, so it doesn't.
Wait.
And do they have their textbooks with them?
I do want to ask because they're
Okay.
all in the school lunch. Or they're not all of them, but
I think it would be best if we do the grade 11s and 12s on Wednesday then, because otherwise we're going to have to wait till 1:45 before the last matrics finish, and that's just...
Can I give this group their page form? Click on top on. For you in grade 12. Yeah, they are.
You in grade 10s?
Yeah, you in grade 10.
Yes.
Take a pen with you, okay?
So we just need to get a message to the matrics, that they won't do their book pledge today, but they will do it on Wednesday. That the Koreans who don't normally do Afrikaans must be not too sure. There's a there is a timetable up there on the front notice on the whiteboard. We can just check. So, yeah, just allowing for the extra timers. Yeah. Okay. Right, well, one of you go to the tourism class and just tell them that we will not. Just hold on, maybe Ms. Bartosh. Ms. Bartosh, are you going to Mr. Jaber's class or must I send someone?
No, they've already sent to you. Their page form across.
Do they know they're not going to go across? No, I'll send someone to tell them. Okay. One of you just go across and tell Mr. Jaber's tourism group. Hold on, Richard. That they've got a pledge form for selling to grade 10s, but their buying from grade 12s will happen on Wednesday. Okay? Right. Okay, Lowry-Bronsted theory of acids and bases says that acids, got a line through it because it's Scandinavian. Acids are proton donors. And bases are proton acceptors. To give you an example, HCl plus water. What's the HCl going to do here? It's going to donate what? Rubbish. An H plus. And what's that going to form? H3O positive and Cl minus. What does that make this HCl? Has it donated or is it received? It's donated, therefore it is the acid. And this is the base. Why is that water the base? Has water got an OH? Not like as clear as that, but it's received an H plus. Okay. What would happen if I gave you this? H2SO4 plus HCl. What have you got there? Two acids. Are they both acids? According to that, yes, acids contain one or more hydrogens, they're both acids. According to this, can they both donate? The one's got to give, the other one's got to receive. Okay? Elements always move between things. They don't just go and float around in space. So, HCl happens to be the stronger of the two. So it will donate the H plus. And what are we going to be left with? You're going to have H3SO4 positive plus Cl minus. What does that make this? An acid, because it donated. And this is the base, because it received. You don't know. You have to know what is known as the Ka value of a compound, which you at this stage don't have a clue about. Okay. Yes? It depends how you look at it. It's a base. according to this theory of what a base is, this definition says that a base is something which receives a proton. It received a proton. According to this, that bases contain an OH. Is it a base according to that theory? No. According to this, it says bases form OH ions in water. Do you see any OH ions there? No. So according to that theory and this theory, that's not a base. But according to the Lowry-Bronsted theory, that is a base because it's received an H+. Okay, so there are about 3 or 4 different definitions of what makes an acid and what doesn't make an acid floating around. We look at acids and bases with things with H's and OH minuses. Okay, but then we get a little bit more clearer, and then we have a look at it in terms of Arrhenius, and next year we'll be looking at the Lowry-Bronsted theory in a lot more detail. Okay, right, we'll leave it there at that stage. I'm going to stop.